Hi guys, I hope you are all doing well. Let's see a question today. So today's question is from the topic of applications of integrals where we need to find the area under the curve. So we have been asked to find the area under the curve and we are continuing our series of questions on JEE Advanced. So this question we have taken it from the year 2016 and the question here says that you need to find the area of the region where x and y both belong to real number square. So real into real. So basically it is given that it is a two-dimensional space. Further, they have told us that y is greater than or equal to root of mod of x plus 3. So we'll also use the ideas of absolute values here. And the second equation that is given to us says 5y is less than or equal to x plus 9, which is less than or equal to 3. So these are the two equations we have been given and we need to find the area of the region enclosed within this. And the options that are given to us for the areas are 1 by 6, 4 by 3, 3 by 2, and the last option that is given to us is 5. So we have to find which out of the four options is correct here, which determines the area of this region given to us. Let's try to solve this. First of all, x and y belongs to real number square. So if I just first plot x and y axis, so on the first page only we will draw the curves that will be there. So this is your y axis and say this is your x axis. So basically this is your x, this is your y axis. So these are the two axes given to us. Now let's solve the equations and then plot the regions whatever we get, and then whenever we get the final region with us we will just find the area there. So if I solve the first part, it's telling me y is greater than or equal to root of mod of x plus 3. If I take the square on both sides, you get y square being greater than or equal to. Now when it is mod of x plus 3, I can have two regions here defined for y square where it can be mod of x plus 3 can be positive x plus 3 when x is greater than or equal to minus 3, right? And if x is less than or equal to minus 3, you will get the value inside the mod as negative. So it would become minus 1x plus 3. So you have two expressions. First of all, to plot the inequality, if I remove the sign of equality and plot equal to, I get y square is equal to x plus 3 or minus of x plus 3. So when x is greater than or equal to minus 3, you get y square is equal to, so for x greater than or equal to minus 3, you get y square equal to x plus 3. And for x less than minus 3, we have y square as minus. So it becomes minus x minus. Now if I try to plot these regions here, I will have y square is equal to x plus 3 will be a parabola touching like being like this, touching x-axis at minus 3 comma 0, because if you put x as minus 3 you get y as 0 here. So if I draw that parabola, let's say my parabola looks something like this, okay? And this idea is y square is equal to x plus 3, and the other was y square equal to minus x minus 3. So it is nothing but opposite c-shaped parabola, again touching x-axis at minus 3 comma 0. So you get y square as minus x minus 3. So both of them will be exactly mirror images of each other. Now further we have been given an equation of line. Let's also plot that. But before plotting the equation of line, first thing, if I understand, it's given to me y square is greater than or equal to mod of something, and mod of something will always turn out positive. That tells me y will always become positive. So if you see the region, actually the lower level of the region won't exist here. So let's understand that. So if I draw only the upper part of the parabola, because y will exist only in the upper side because it's a positive value. So your parabola will look something like this. The parabola looks something like this. And the other parabola y square equal to minus x minus 3 will also be both of them intersecting at minus 3 comma 0. Now we will also have to identify whether the region is below the parabola or it is above the parabola. So what I can do here is I can take a point here. Let's say if I take 0 comma 0, because I know that point is in there. If you want to find this point also, you get the y-intercept. So if you want to find this point, basically you are taking x as 0. So you get y square is equal to 3 and mod of 3. So basically positive y is equal to root 3. So you get this as 0 comma root 3. So this is the value here for this coordinate. Now we need to find out whether the region lies below the parabola or above the parabola. Let's find that out first. Then we will plot these equations of line also and understand the common region between the four curves. So first of all, let's understand. Now I have origin point here. If I substitute origin point, I have been given y square is greater than or equal to x plus 3. So if I put origin point here, 0 and 0, I get a condition 0 square is greater than or equal to mod of 3, that is, or yeah, mod of 3. We are getting a condition here that says 0 is greater than or equal to 3. But is it true? 0 is less than 3. So we get this condition is always false. And when we are getting this condition always false, that means basically the point or the region where origin lies, that is not our feasible region here. So when that is not the feasible region because the origin does not satisfy, that means the region won't be below the parabola, it will be above the parabola. So when I see the common region after just plotting the two curves, I understand the common region will be above the parabola like this. So this will be the common region. But let's also plot these two lines. We will get two more regions. So we will get a common region there. Let's find that out. So if I try, the first equation which is given to me is 5y less than equal to x plus 9. That's less than equal. So what I get here is one equation is 5y less than equal to x plus 9. The other equation I get for line is x plus 9 less than equal. So if I remove the inequality for the second part of equation of line, I get x plus 9 is equal to 15, x is equal to 6. So if I plot that, x is equal to 6 will be somewhere here. Let's say x is equal to 6 is somewhere here. So you get a line which is parallel to y-axis because we have the equation x is equal to 6. So you get a straight line here. Let's draw a straight line. So we get a straight line parallel to y-axis that says x is equal to 6. We have got that region also. Now it's given to me that the condition says x is less than or equal to 6. Right? So if it is less than or equal to 6 means I understand the common region will be anywhere to the left of 6. So I understand one idea that after plotting the two curves, I got the common region all above the parabola, but now I have it x less than 6. So it is to the right of x equal to 6 now. Oh, sorry, left of, not right. When you have the region to the left, now let's plot the last equation of line and we will get the common region. Let's see. So if I try to plot this line now, instead of inequality, if I plot it as equal to understand how the line behaves, I get y is x by 5 plus 9 by 5. Now comparing it with y equal to mx plus c, you get slope is 1 by 5. So when you have a positive slope, you get an ascending line, and c being 9 by 5, 9 by 5 if you solve it, get 1 point, much like 4, so 1 point. So you get 1.8. And if you see this point, this is 0 comma root 3. Root 3 is 1.732, right? So basically 1.8 will lie somewhere above on the y-axis. So let's say this is 0 comma 5 by 9. So your line will pass like this, being a ascending line passing through like this from 0 comma not 5 by 9, 9 by 5. So get that as 9 by 5. Now if I try to draw a region, basically I will have a ascending line like this, just passing through like this, which is going to intersect basically your parabola also in 2 points. Now let's try to find the points of intersection here. If I want to find the points of intersection, let's see. So if I want to find the point of intersection, I was told 5y is equal to x plus 9 was one curve when I took it as equal to, and the other curve told me y square is x plus 3. So instead of x, if I write down, I get x as 5y minus 9. Basically, what I'm trying to do is I'm trying to find the intersection points that are there with the line at the parabola, which is there, y square equal to x plus 3. So you have here x as 5y minus 9. If you substitute, you get y square as 5y minus 9 plus 3. So y square becomes 5y minus 6. So y square minus 5y plus 6 is equal to 0. If you try to solve this quadratic, you get y square minus 3y minus 2y plus 6 equal to 0. I common y minus 3 minus 2 y minus 3. So you get here y minus 3, y minus 2 is equal to 0. You get 2 points of intersection. One is y equal to 2 and y. We have got the y coordinate for the point of intersection. Let's also find x coordinates. We know x is 5y minus 9. So if I put y as 2 here, I get x is 1. So one coordinate is 1 comma 2. The other coordinate, if I put x as 3, so it becomes 5 into 3, 15. 15 minus 9 is 6. So I'm getting 2 points of intersection of the parabola with the line. One is exactly at this point, if you understand. Because our 6 was the x coordinate here, it is exactly 6 comma 3. And the other point of intersection is this, which is 1. So you have this 1 comma 2. This becomes 1 comma 0. Now let's try to find the other points of intersection. Basically the point of intersection of this parabola with the line. Again, it will also have 2 points of intersection if I draw these lines. But let's try to find the one point that is forming the region here. Let's see that. So now if I make that, find that point, you understand one curve is y square equal to minus x minus 3. The other is your equation of line 5y equal to x plus 9. So again, you get x as 5y minus 9. If you substitute this point here, you get it as y square is equal to minus of 5y minus 9 minus 3. So you get y square equal to minus 5 plus 9 minus 3. So y square becomes plus 5y and plus 6 goes here, becomes minus 6. If you solve this, you get y square plus 6y minus y minus 6 equal to 0. Y common, y plus 6 minus 1, y plus 6. So you get this as y equal to 1 and y equal to 6. Now you got y as 1 and y equal to minus 6 means basically this line is going to intersect here at 1, and then that line is going to intersect the parabola at minus 6 when y is minus 6, so the third quadrant. But we don't need y negative here, we need only positives for y. So if y is positive, let's find x there. We already know x is 5y minus 9. So 5 into 1 minus 9, you get minus 4. So you get this coordinate becomes minus 4 comma. So you get this point of intersection also minus 4. Now here if you see, we already had the common region. Let's talk about that. So common region we had already, that was saying that it is above the two parabolas and to the left of this line x equal to 6. But now let's find out whether the region for this line is above or below. Now if you see this equation or origin is present below the line. So if I plot these points of origin in this equation of line, so let's put that. So if you plot origin points y is 0 less than equal to 0 plus 9, 0 less than equal to 9, that is always true. When you get this condition being always true, you understand that basically the entire region is below the line. So if you make sure, let's plot this now. So I'll erase this curves. Yeah. So we know already from the first two parabolas that it's going to be above the line or above the parabola slot line. And the other idea told us that this is going to be to the left. So we got this entire region here, and now it's telling me it is going to be below. So below this line. So if it is going to be below this line, I understand the common region which will be there for this four regions will be this one. So basically the entire region here. So only this much region, we need to find the area of this region. Now what I can do here is I can understand this, that if I actually draw it correctly, you had a region like this, a region is present where this coordinate is known minus 4, 0. This is known minus 4, 1. This is known as 1, comma 2 and 1, comma 0. And we had the two parabolas also, if I plot that. Basically, I've had this parabola like this and this parabola like this. So this point was minus 2. So we had this area of the region that we need to find. So first of all, what I can do here is to find this area of the region required. That is nothing but area of trapezium. Let's name the points. Let's say A, B, C, D, and so you get area of trapezium ABCD minus area of this part, that is ADE, and area of this part, that is BC. So let's plot, let's find these areas individually and then we'll substitute to get the area of the required region here. So area of trapezium, let's find that out first. So if I find area of trapezium, it's half into sum of parallel sides into, you have half into sum of parallel sides. If you want to find out, I can see these are the parallel sides. This side is of length 2 units, this is of 1 unit. This because we are just finding the difference between the y coordinates in both the cases since it's the same, because these are parallel. And the height, if you see, it's going from coordinate x coordinate 1 to x coordinate minus 4. So if this is the origin, let's say 0 comma 0, you have here 1 units distance and here you have 4 units distance, so height becomes 5 here. Now let's find that. So when the height becomes 5, you get half into sum of parallel sides. Parallel sides have the distance 2 plus 3, 2 plus 1, not 3, and height is 5 units. So you get this as 3 into 5 by 2, that is 50. So this is your area of trapezium, 15 by 2. Now let's figure out the two remaining areas that we need to solve for. Area of curve ADE and area of curve BEC. So area of curve ADE, if I see, the limits go from x1 to x2 because you're finding the area under the parabola by dx. x1 to x2 means your limits go from minus 4 to minus 3. Y is nothing but root of minus x minus 3. You get that as minus x minus 3 raised to 3 by 2 upon 3 by 2 and dividing by the coefficient of x, that is minus. So you get minus 2 by 3. Here if you substitute minus 3 plus, first you get minus of minus 3, that is 3 minus 3, 0. Minus, if you substitute minus 4, you get minus of minus 4, 4. 4 minus 3 is 1, 1 raised to 3 by 2 is 1. Get the area is 2 by 3. Now the next region, if you want to find out here, It's nothing but area under the curve BEC. So if you find that area of BEC, again the limits will go from x1 to x2 y dx. If you see the limits here, it now goes from -3 to 1, and the root of x plus 3 you are finding out. You get that as x plus 3 raised to 3 by 2 on 3 by 2. Limits go from -3 to 1. So you get 2 by 3. 1 plus 3 raised to 3 by 2. So 4 raised to 3 by 2. Minus, if you put -3, you get that as well. So you again get 2 by 3. Square root of 4 is 2. 2 cube is 8. You get it as 16. So you get the area of the other region also 16 by 3. Now you just need to put it in the values to get the area of required region. So you had first 15 by 2 minus. The other came out 2 by 3 and the other came out 16 by 3. So 2 by 3 and 16. So you get 15 by 2 minus 18 by 3. 18 by 3 is nothing but 6, right? So 15 by 2 minus 6. If you solve 15 minus 12, that is 3. 3 by 2 is the answer for the question. So you get the answer here as 3 by 2 for the question which is given to us. You get the answer as 3 by 2 here, and if you see the option here which matches with the question given to us, is C. So C is the correct answer for the question. I hope you have understood how to solve these questions where areas of the region you have to find it out. So first we figured out the two curves of parabola, then two straight lines, then we found out the common region, that was basically the region in red. Once we figured that region out, we found the points of intersection also of the parabolas with the lines. Then we got that area of required region is nothing but area of trapezium minus this area minus the other area. So you figured out area of trapezium using the formula and area of other two regions using applications of integrals. So that gave you the regions. And once you figured out that, you got the area of the required region as 3 by 2. That is option C. I'll meet you again tomorrow with some other question from some difficult topic of JEE Advanced. Till then, you can like and share these videos with your friends who are also involved in the preparation of JEE Advanced questions. Also, subscribe to my channel. Thank you.